What if the first visitors from another star are not just random rocks, but mysterious messengers carrying secrets of other worlds? When Oumuamua streaked into our solar system in 2017, it shook astronomy to its core. It wasn't just its strange speed or bizarre pancake shape that baffled scientists. It was the haunting question: what was it, really? For decades, we had only imagined visitors from other stars. Suddenly, one appeared, and nothing about it made sense. Some believed it was a comet. Others argued it might be an asteroid, and a few whispered the unthinkable. Could it be artificial? Years later, new research revealed an unsettling theory. Oumuamua might not be a comet at all, but a fragment of an exo-Pluto, a frozen world shattered in another star system and flung into the darkness of interstellar space. Imagine a shard of another planet, traveling for billions of years, until it finally brushes past our sun. But Oumuamua was only the beginning. Since then, more cosmic strangers have arrived. 2i Borisov, and now the most mysterious of them all, 3i Atlas. Unlike its predecessors, Atlas is different. This time, we are watching it inbound, unfolding in real time as it draws closer, revealing its secrets under the sharp eyes of the James Webb Space Telescope. When the James Webb Space Telescope turned its golden mirrors toward 3i Atlas, astronomers expected another blurry streak in the darkness. But what they saw instead was breathtaking. For the first time in history, an interstellar visitor was revealed not as a faint smudge, but as a resolvable body, a world fragment glowing with detail. Its surface shimmered with patches of reflective ice, while darker scars traced across it like battle wounds from an endless voyage. This raised a burning question: is Atlas a comet, or an asteroid, or something entirely new? The truth is unsettling. Atlas seems to be both. Its icy surface tells us it behaves like a comet, producing a faint coma, a halo of gas and dust, as the sun warms it. But its fractured, rocky scars suggest it carries the strength of an asteroid, a hybrid born in the violent outer reaches of another star system. And then came the shocker. Webb's instruments detected something strange in its composition. The coma was dominated by carbon dioxide, in a ratio unlike any comet we have ever studied in our own solar system. Why would a visitor from another star carry such an alien chemical fingerprint? Was it born under conditions completely different from our sun's neighborhood? Or has its long journey through deep space transformed it into something new? Astronomers leaned closer to Webb's data, searching for answers. What they found only deepened the mystery. Alongside carbon dioxide, Atlas's coma also carried traces of carbon monoxide, but in bizarre proportions. Normally, these two gases travel hand in hand, yet here the balance was broken. Why would Atlas carry so much carbon dioxide, but so little carbon monoxide? On Earth, on Mars, and even in comets from our own Oort cloud, chemistry follows predictable rules. But Atlas was breaking them. And in science, when nature breaks its own rules, it often means one thing: we are seeing something completely new. Some theories suggest Atlas was forged in the icy outskirts of a young star system, where exotic ices froze into its surface. Others wonder if billions of years of interstellar radiation reshaped its chemistry, stripping away familiar elements and leaving only the strange. And remember, Atlas is not just any fragment. Unlike Oumuamua, which surprised us as it was leaving, Atlas is arriving. That means we can track it as it approaches the sun, watching its surface change, watching its coma grow, watching its secrets unravel in real time. Every week, new data flows in. Soon it will swing by Mars in a close flyby, giving NASA's Mars Reconnaissance Orbiter a rare chance to photograph an interstellar visitor up close. For astronomers, it feels like the cosmos has delivered a gift, a living time capsule from another world, right to our doorstep. But then came a question that refuses to die. What if these visitors are not just natural objects? Ever since Oumuamua, whispers have echoed through both scientific halls and late-night conversations. Its strange, elongated shape, its odd acceleration away from the sun. Some said it behaved more like a spacecraft than a comet. Of course, science demands proof, and natural explanations are always tested first. Gas venting, icy fragments, tumbling motion. Reasonable theories. But still, the unease remains. So how would we know if an object like Atlas was artificial? Researchers have proposed 4 technosignatures, 4 clues that could betray alien engineering. Unnatural movement. If an object moves in ways no cometary gas or asteroid physics can explain, that's a red flag. Unnatural spectra. Telescopes reveal what things are made of. If light reflects off polished metals, glass, or strange alloys instead of ice and rock, suspicion grows. Unnatural shape. A comet may be lumpy, but a perfect solar sail rectangle? A battle cruiser silhouette? That would be hard to dismiss. Signals. The smoking gun. If an interstellar body beamed radio waves, laser pulses, or any form of communication, it would change history overnight. So far, Atlas shows no such signs. Its spectra reveal ice, dust, exotic molecules, but nothing that screams technology. And yet, the possibility lingers. Each new visitor is scanned not just with curiosity, but with hope. Hope that maybe, just maybe, the galaxy is whispering back to us. While Atlas pulls our gaze outward, other worlds in our own solar system are revealing their secrets too. Take Mars, for example. For decades, we wondered what truly lies beneath its rusty surface. Thanks to NASA's InSight mission, we now know the red planet hides more than just rock and dust. The seismometer on board listened carefully. Over 1,000 Marsquakes, like a doctor pressing a stethoscope to a patient's chest. And what it revealed shocked scientists. Inside Mars are massive blobs of dense material, floating adrift deep within the planet. These are not ordinary structures. They are likely the relics of ancient colossal impacts, catastrophes from over 4.5 billion years ago when the solar system was young and violent. Giant asteroids slammed into Mars, breaking pieces of its interior and leaving scars that still linger today. Imagine chunks the size of mountains, slowly sinking, reshaping the planet's insides over billions of years. And Mars is not alone in offering new puzzles. Look at Jupiter, our solar system's giant. Its magnetic field is so powerful it dwarfs Earth's, funneling solar wind particles into glowing auroras. But unlike Earth's neat rings of light near the poles, Jupiter's auroras are different. They fill in the poles themselves, glowing in ultraviolet light invisible to human eyes. The Juno spacecraft revealed this hidden beauty, uncovering plasma waves, strange currents, and dazzling storms of particles. For astronomers, it's a reminder that even in our own backyard, the rules of physics write stories we've never read before. But not all stories in space unfold smoothly. Sometimes, even our most advanced spacecraft slip into silence. This happened recently with ESA's JWST mission, a probe on its way to study Jupiter and its icy moons. In July, controllers suddenly lost contact with the spacecraft. No signals, no data, just silence. And this wasn't a minor glitch. JWST was only weeks away from a crucial Venus flyby that it needed to reach Jupiter in 2031. Engineers had 2 choices. Option 1, wait. After 14 days, JWST would reboot automatically and hopefully re-establish contact. But waiting meant risking the flyby. Too dangerous. Option 2, try something bold. They began sending blind commands into the void, hoping the spacecraft might hear them. For almost 20 hours straight, the team worked without rest, every command taking 22 minutes just to reach the probe across deep space. Imagine the tension. Every instruction a desperate whisper, unsure if anyone was listening. And then, finally, a reply. JWST woke up. Contact restored. Relief swept through mission control just in time. On August 31st, the spacecraft performed its flyby of Venus perfectly. The mission continues its journey to Jupiter, carrying humanity's hopes to uncover the secrets of Europa, Ganymede, and Callisto. But this close call was a reminder. Space is unforgiving. Even the smallest glitch can end decades of preparation. While spacecraft fight to survive in deep space, the universe itself reminds us of its violent beauty. One of the most haunting sights lies 11,000 light-years away, the shattered heart of a dying star known as Cassiopeia A. When this star exploded centuries ago, its death cry echoed across the galaxy. Today, we watch its wreckage expand outward in real time. And thanks to the Chandra X-ray Observatory, astronomers peered deep into its heart and discovered something astonishing. Inside the supernova's core, elements like silicon and neon are no longer neatly layered. Instead, they are violently mixed. Silicon smashing through neon shells like cosmic shrapnel. This chaos explains a mystery. Why do some neutron stars race through the galaxy at incredible speeds? The answer lies in the asymmetry of the explosion, where uneven blasts act like rocket thrusters, kicking stellar remnants across the cosmos. And then, closer to home, our own star unveiled its fury. The Daniel K. Inouye Solar Telescope, the most powerful solar observatory on Earth, captured the highest resolution image of a solar flare ever seen. An X-1.3 class flare, spanning a region many times larger than Earth, was revealed in unimaginable detail. Astronomers saw filaments thinner and more fragile than expected, like glowing threads unraveling from the sun's surface. To achieve this, the telescope uses an extreme cooling system, circulating 11 kilometers of coolant piping just to survive the heat of staring directly at the sun. These images are more than beautiful, they are warnings. The same solar storms that paint auroras in the sky can also disrupt satellites, power grids, and even spacecraft exploring the edge of our solar system. Not all cosmic wonders are violent. Some are delicate, fragile, almost poetic. When the James Webb Space Telescope turned its gaze to newborn and dying stars, it captured visions that astronomers now call cosmic butterflies. The first was a protoplanetary system nearly 525 light-years away. Unlike most disk images seen face-on, Webb caught this one edge-on. Instead of rings, we see the true thickness of its dust disk, a shadowy lane cutting across the light of a young star. From its poles, streams of gas shoot outward, jets of matter carving through space. These are the raw ingredients of planets, caught in the act of forming. To look at it is to witness a solar system in its infancy, a mirror of what ours might have looked like billions of years ago. But Webb also turned its eyes to the other end of the cosmic story, the Butterfly Nebula, or NGC 6302. Here, a dying star sheds its outer layers, releasing clouds of dust and carbon-rich molecules into the galaxy. Seen edge-on, its outflows spread like wings of smoke, delicate and glowing in Webb's infrared vision. Astronomers describe it like a cosmic campfire, scattering dust that will one day seed new stars, new planets, maybe even new life. In these two images, one of birth, one of death, Webb shows us the cycle of the universe itself. Stars are born, they live, they die. And in dying, they give the building blocks for worlds yet to come. Each of these discoveries is awe-inspiring, but the mystery of interstellar visitors still looms above them all. In just a few years, we have seen 3, ʻOumuamua, 2I Borisov, and now 3I Atlas. ʻOumuamua stunned us in 2017. It was thin, elongated, unlike anything in our solar system. Some thought it was a comet, others an asteroid, and a few dared to ask, could it be a probe? Then came Borisov in 2019. Unlike ʻOumuamua, Borisov looked more familiar, a comet with a visible tail. It reminded us that many of these wanderers may just be icy bodies, flung across the galaxy. But Atlas is different. It's larger, several kilometers wide, and its composition is unlike any comet we know. Its strange CO2 to water ratio and faint carbon monoxide signature hint that it was born in conditions alien to our solar system. A hybrid, both comet and asteroid, carrying chemical secrets we have never seen before. And perhaps the most important difference, Atlas is inbound. We are watching it live, unfolding moment by moment, instead of catching only a glimpse as it leaves. Its close encounter with Mars, its perihelion in October, its brightening coma, all of it gives astronomers a front-row seat to study an interstellar object in action. Each visitor is unique. Each is a messenger from another world. And together, they tell us one undeniable truth. The galaxy is not empty. It is alive with travelers, drifting endlessly between stars. If Atlas and others like it carry exotic ices and organic molecules, then their importance goes far beyond astronomy. They may be the delivery systems of life itself. When Webb split Atlas's light into spectra, it revealed unfamiliar organic molecules, compounds rarely seen in our own comets. To chemists, this was thrilling. These molecules are the raw ingredients of biology: carbon chains, exotic bonds, the building blocks of proteins and cells. And here's the thought that sends shivers down the spine. If such compounds are common in interstellar objects, then life's recipe is scattered everywhere across the galaxy. This idea is called panspermia, the possibility that planets like Earth were seeded by material from other stars. Imagine an early Earth, battered by countless impacts from icy comets. What if some of those comets weren't local? What if fragments like Atlas delivered alien chemistry to our young oceans, sparking the first steps toward life? If true, then life on Earth might not be unique at all. It could be part of a galactic tradition, repeated again and again, wherever conditions allow. Even if Atlas carries no microbes, the molecules it holds could still matter. They are chemical toolkits, packages of potential, waiting to meet the right environment. And with every interstellar traveler that drifts through our skies, the galaxy whispers the same possibility. Life may not just arise on planets, it may travel between them. The more we study these interstellar visitors, the clearer one truth becomes: they are not rare. For billions of years, planetary systems across the galaxy have been scattering fragments into the void, shards of icy worlds, rocky asteroids, even Pluto-like surfaces. In our own solar system's chaotic youth, Jupiter and the giant planets hurled countless bodies outward. Some crashed into the sun, some were flung to the Oort cloud, and many more escaped entirely, vanishing into interstellar space. If our system did this, then every other system likely does too. That means the Milky Way is filled with wanderers, millions, maybe billions of them, traveling silently between the stars. And Atlas is proof of this. If we have detected 3 interstellar objects in only a few years, it suggests there could be trillions drifting out there, unseen. Some are small, fragile, like ʻOumuamua. Others are larger, intact, like Atlas. Together, they paint a picture of a galaxy in motion, constantly trading material between systems. It's like a grand cosmic highway where fragments travel for millions of years before brushing past planets like ours. And each one carries a story of its parent star, its collisions, its journey through radiation and darkness. When Webb captured Atlas, it wasn't just photographing a comet, it was recording a chapter of galactic history. When we look at Atlas, or ʻOumuamua, or Borisov, we are not just seeing rocks drifting in space. We are seeing fragments of alien worlds, silent travelers that carry whispers of other suns. For humanity, this is humbling. For the first time, we can say with certainty that matter from distant star systems has brushed past us. Tangible, observable, real. We are not isolated, we are connected. Every detail Webb captured, the shimmering ices, the scars, the faint coma, is a reminder that we live in a galactic web of matter in motion. Our solar system is only one node in this network, exchanging debris with countless others. And in this realization comes something deeper. These wanderers remind us of impermanence. Atlas will not linger. Its hyperbolic path ensures it will leave, never to return. But for this brief moment, its image is etched into human knowledge forever. There is poetry in this. A shard of another world, traveling for millions of years, arrives at the exact moment when our species finally has the technology to see it clearly. The odds are astronomical, yet here we are, face to face with a messenger from another sun. It is as if the cosmos chose this moment to speak to us, reminding us of our place in a vast, restless galaxy. So, what does all of this mean for us? ʻOumuamua, Borisov, Atlas. Each is unique, each carrying a different story. Yet together they form a pattern. They tell us the galaxy is alive, trading fragments, scattering chemistry, shaping worlds. Astronomers now believe interstellar objects are far more common than we once imagined. If 3 have crossed our path in just a few years, there could be trillions more drifting silently, waiting to be discovered. Each one a time capsule, each one a chance to glimpse another system's history. For science, these visitors are priceless. They refine our models of planetary formation. They test our theories of chemistry and astrobiology. And they whisper possibilities, that life itself might be a galactic phenomenon, carried from star to star by wanderers like Atlas. For humanity, they are something even more. They are symbols of connection, of impermanence, of curiosity fulfilled. To see an object from another star, to study it with the sharpest eyes we've ever built, it changes how we see ourselves. We are no longer bound to a single system. We are participants in a cosmic dialogue. Atlas will soon leave, its path carrying it back into the darkness. But its image, its chemistry, its story, those will remain with us. And someday, when the next interstellar visitor appears, we will be ready. Because now we know, the universe is not distant, not silent. It is here, moving past us, one mysterious traveler at a time. The universe is not silent, it is speaking through its travelers. What do you think? Are interstellar visitors like Atlas just frozen fragments of distant worlds? Or could one of them someday turn out to be something far more mysterious? Could interstellar objects be more than just frozen rocks? If this story amazed you, make sure to like this video, share it with friends, and tell us your theories in the comments. We'd love to hear them. And don't forget to subscribe with notifications on, so you never miss the next mystery from the universe.